All right, so we are going to look at some more interesting graphs today. The first one is still, I would say, along the kind of boring side of the rational graphs, but that's because I'm going to add one piece to this that we need to check that we didn't check yesterday. All right, so we start off by factoring, right? So this becomes x minus 3 times x plus 1 over x plus 1 times x plus 2. So do I have point discontinuity? Yes, I do. So I'm going to cancel that out. That makes the x value of the whole -1. And then my reduced function is x minus 3 over x plus 2. So I substitute in the -1. That'll give me -4 over 1, which is just -4. How many roots do I have? 1. And I write them in set notation, right? Or I write it in set notation. Vertical asymptotes, I have how many? 1. And it is an equation of a line. Do I have any tangency of togetherness? No, we haven't talked about how to handle it yet, but you should at least be able to notice whether or not you have it. Clearly we do not have it, so none. Do I have a horizontal asymptote? Yes. It is at y equals 1, which means I do not have a slant asymptote. My y-intercept is when x is 0, so that'll be 0, -3/2. Okay. Everybody good with that? Okie dokie. So I'm going to rewrite that reduced function down here so we can see it. I did change the wording and put sign chart here instead of number line. And what was it? It was x minus 3 over x plus 2. Okie dokie. So there's two things that go on here. We got a -2 and a 3. Is the -2 opened or closed? Open. And the 3 is closed. Okay. So then we check for points here, or check our points. So -3 I'll use, so I get negative over negative, which is positive. I could use 0, which is negative over positive, which is negative. And I could do 4, which is positive over positive, which is positive. Then I shade positive, negative, positive. Everybody with me? Okay, so on our graph, let's go put our asymptotes on here. We have one at x equals -2 and one at y equals 1. Okay, can I ever cross a vertical asymptote? Vertical. No. Can I ever cross, because it's what? It affects domain, exactly. Can I ever intersect a horizontal asymptote? Yes. Can I intersect it more than once? Yes, it could be an infinite amount of times, right? So one thing we didn't do yesterday was check for that, okay? But the ones I gave you, we didn't intersect it, so I just didn't want to do too much in one day. So we need to check to see if we intersect this asymptote or not, because nothing we've done so far tells us that. So let's think about... So one thing you did, and that you've done quite a bit, is if you wanted to know where two lines intersected, you could plot the two lines and then, boom, see where they intersect, right? So that doesn't necessarily help here because we don't know how to graph it. So what could you do algebraically to figure out where two lines intersect? What was that process that you did? Say that again. Plug in the values, meaning like substitution, right? Or what's the other thing you could do? Substitution or elimination, okay? So elimination doesn't necessarily work here, but substitution will. We have two functions, and I think I made mention a week or so ago that, you may have the false concept because the only way you've ever done systems was with lines, right? You had two lines, you wanted to see where they intersect, that was your systems of equations, you've done it a lot, but it was probably mostly always with lines. That gives you a false understanding maybe that only works for lines, and that's not true, it works for anything. So I have this function. I want to know where my function and my asymptote intersect. So I can treat it like a system of equations. Okay, does that make sense to you? So I'm going to rewrite them down here. Okay, so this right here is, this is equal to y, right? So here are my two functions. I have y equals x minus 3 over x plus 2, and I have y equals 1. And I want to know where do they intersect, if they intersect. Maybe they don't. That's what I'm trying to figure out. If they do, I need to know where. If they don't, I need to know that as well. So I'm going to use substitution because elimination would really not make any sense here, right? So y equals 1. I can take this 1 and substitute it where y is. So I can say 1 equals x minus 3 over x plus 2. So I want to know when y equals 1, do they have the same x value at any point? So I would like to get rid of my fraction, so I'm going to multiply both sides by the denominator. So this times 1 just gives me x plus 2 equals x minus 3. Then I can just, when I subtract x from both sides, I get 2 equals negative 3. Does that make any sense at all? 2 definitely does not equal negative 3. So if you get some nonsense like that, what that tells you is that they don't intersect. They're never going to have the same x value, okay? They're not going to intersect, is what I'm trying to say. And if they did, I'd get like x equals 5. Then I would know that they intersect at 5. Okay, and we'll get one that does. But if you get nonsense, that means it doesn't intersect. We can treat it just like we were doing everything else yesterday. Okay, but something we have to know to be able to get it done. Okay, so then let's plot some points here. Or let's put up the rest of our stuff on here. We have a hole at negative 1, negative 4. Negative 1, 1, 2, 3, 4. Put the hole there. I have a root at 3. I have a y-intercept at 0, negative 3/2. I already did my asymptotes. I think that's all the information I have. Do you agree with that? Okay. So one thing I wanted to show you over here that I forgot before we started plotting was what this kind of tells us. This tells us we know we have a vertical asymptote here. It's positive the entire time. So it's going to have to look something like this. But then we had to decide whether or not it was going to intersect that asymptote. Then, since I don't have any togetherness, it has to start down here, like this, and it's going to have to cross through that point at 3, and then it's going to have to be positive, and since I have some sort of asymptote, it looks something like this. This is totally not to scale, because I didn't care about it being to scale for my sign chart, but it gives me an idea of what's happening with my graph, right? So if this is all I have to plot, even though I know all of this is just positive right here, I need at least 1 point to plot over there, okay? And sometimes you need more, and we'll look as we go through this how you know if you need more than 1. So I like to pick just 1 point on the other side of the asymptote. So let's use negative 3. I need to find f of negative 3. So f of negative 3, that would be negative 3 minus 3, that's negative 6. Negative 3 plus 2 is negative 1, so that's just 6. So I can go to negative 3, 1, 2, 3, 4, 5, 6. All right, so I feel like that one really isn't enough because it could come straight down like this, or it could swing out kind of far like this. Like I need at least 1 more to kind of get me a better idea of the shape. So let's try f of negative 4. F of negative 4 is going to be negative 7 over negative 2. So it's like 3.5. Right? So I can go to negative 4, 1, 2, 3.5. And that's probably enough because if I'm doing this, it's not going to like turn and be straight. It doesn't make any sense. It's got a curve. You can just kind of follow the natural curve of things like so. And this part right here might not be 100% accurate. I mean, without getting another point, but it's good enough for what we're doing. We're fine. Okay. So then when I go on the other side of the asymptote, I don't have any togetherness, and I know it's negative. So I know it starts down here, goes up through here. It becomes positive at 3, and I know that it does see, because the possibility is that it could come up and come back down, but I know for a fact that it doesn't because I checked to see if it intersected. So it's just going to come under here. I don't feel like I need any other points. Just make sure, and I have to stand in front of it in order to not make it look super weird. Make sure you don't draw straight through the hole because then it kind of loses the point of being a hole. Looks something like that. And I missed that point, so I'm just going to make it bigger. And speaking of points, your points that you plot don't have to be ginormous. But if you make tiny little points and then your pencil's kind of thick and when you draw over it looks like you don't have any points, when I look at it, I think you don't have any points. I got to be able to see them. That doesn't mean you have to make them giant. It just needs to be obvious that there's a point there. Okay? What questions we got? We good? You see how it's a puzzle that you put together? All right. Let's look at another one that's a little bit more interesting here. So let's factor. This is going to be -6, and then I just thought of something. Who's already folded theirs? Can I see your? I didn't say this last period, and I might forget at the end too. This one, because we have a graph on the back. Well, we have a graph on the back. We're not going to get to number 4 yet. Today, we're going to get to it on Monday, so you may not want to tape it in at all. But when you tape it in, because if you tape it down like you did yesterday's, then you can't see number 4, right? If you put it in your ISN and you just put like a piece of tape there, it can just kind of be like a little flat book. Does that make sense? So just giving you away so you don't tape it closed and then you can't read it. It just occurred to me. I didn't say that last period. X minus 3, but again, you may not want to tape it in at all just yet because we're not going to finish. X minus 3 times X plus 2. All right, do I have any zeros? No. So do I put the empty set? No, I said that wrong. You're right, I don't have any zeros. I should have started with holes is what I was thinking. Do I have any point discontinuity? No, I don't have that either. Do I write this as an empty set? No, I write this as none. I don't have any zeros either, because I already asked you that. But I don't write that as none. That is the empty set, because it was a set of things I have nothing to put in. How many vertical asymptotes do I have? 2. Do I write them as a set of numbers? No, because they are lines. You write them as equations of lines. X equals 3, comma, X equals -2. Do I have any tangents here or togetherness? No. Do I have a horizontal asymptote? 0. Y equals 0. Yes. Y equals 0. It's bottom heavy, so it's Y equals 0. My y-intercept is easier to figure out from this form right here, because if all my x's just zero out, I get -6 over -6, which is 1. All right, so let's do our sign chart. I'm going to rewrite this. F of x equals, no, I'm looking at the wrong one, -6 over x minus 3 times x plus 2. So I have 2 things that go on my sign chart, -2 and 3. All right, so on the -2, is it open or closed? Open. Is 3 open or closed? Open. All right, so I'm going to substitute in a -3. Now, in the numerator, I do not have any variables. I'm not substituting anything in, but that is a -6. That negative in the numerator matters. So I'm going to put him down before I worry about substituting stuff in. -3 right here gives me a negative times a negative, so those 3 together give me negative overall. Can substitute in a 0 here, so I have a negative in the numerator, and then negative, positive, that's positive overall. Then I have 3, or I'll use 4, I'm sorry. I have a negative in the numerator, then positive, positive, then negative overall. So negative, positive, negative. Everybody good? All right, so let's put in our asymptotes. We have one at -2, one at 3 for the vertical, and then my horizontal is at y equals 0. Okay, so I want you to just take a second. I want you to look at your sign chart. I want you to look at your asymptotes. And I want you to see if, like, in your mind, you can visualize what this graph might look like before we start doing anything else. You don't have to sketch it or anything, just think about what might have to happen. Okay. All right. Now, remember, we have to check to make sure, we have to know, rather, whether or not the function is going to intersect the asymptote. I know for a fact this one is not going to, and I don't have to check anything algebraically like we did on the last one. Why would I not have to do that on this one? Because it's at 0, exactly. If the function intersected the asymptote, I would know because I would have a 0 there. Does that make sense to you? So when it's on the x-axis, you shouldn't have to check algebraically. If it intersects, it would have been one of your zeros, which can happen for sure. Since I don't have any zeros, I know I'm not going to cross the x-axis, so I know I'm not going to cross this asymptote, so I don't have to check algebraically. If you did check algebraically, then you would get a weird 2 equals negative 3 thing again. It wouldn't hurt anything, we just don't need to. All right, so let's plot what we do know. We don't have any holes, we don't have any roots, we did our asymptotes. I only have one point to plot, and that is at 0, 1. Okay. Well, remember over here, these are our vertical asymptotes. From negative infinity to negative 2, this whole thing down here is negative. So I know it's going to have to look like this. I just need to get a point in there, at least one. So my asymptote's at negative 2. Let's find f of negative 3. So f of negative 3, that gives me a negative 6 in the numerator. Then I'd have negative 6 times negative 1. So that's just a negative 1. So negative 3, negative 1. I feel like that 1 point is definitely enough because that tells me it hugs up in real close to where those asymptotes are. And this section of the graph looks like this. Okay. All right, so then I go into this middle section. Well, I just have this 1 point. And what do you think this middle section in between these two asymptotes is going to look like? Like a parabola. It's not a parabola, but it looks like a parabola, which is what you said, what you meant. But I'm going to make sure you understand after we draw it why we know for sure it's not actually a parabola, even though it might look just like some that you've graphed. So I do know, and the reason I know that is because, first of all, I don't have any togetherness, so I can't be down here. Plus, I know it's supposed to be positive. And the way asymptotes work, it has to be here, and it has to be here, and I can't cross the x-axis, so I'm going to have to turn around and go back, right? But I would like to know maybe where my minimum is, my relative minimum. I don't know that this might be it. It might not be it. We'll see. But let's just find one more point. Let's find f of 1, just to see if we can see what's happening here. So if I find f of 1, it's going to give me negative 6 over negative 2 times 3, which is a negative 1. No, it is not. It's a positive 1. I messed this one up real bad last period. I substituted in, and I got lucky. Basically, I did something stupid here. I don't know, but I still got 1. Whatever. So when I'm at 1, I'm at 1. So what that tells me is, I don't know exactly where my minimum is, but I know it's somewhere between 0 and 1. Right? Does that make sense? Okay, good enough. So I can sketch this in. Looks something like this. A bit better. Looks totally like a parabola. If I did graph a parabola, though, so here's my parent function, y equals x squared. What is the domain for the parent function of a quadratic? All real numbers, right? Because it keeps going up like this, even if they look tall and skinny. Is the domain of this section all real numbers? No, for sure not, because we have an asymptote, right? So like I said, it might look exactly like some you've graphed, but totally not, because it's still just going to go straight up. Okay, so then we have this last section. And from 3 to infinity, I know it's negative the whole time, but I need at least 1 point over here, so let's try 4. So f of 4 equals negative 6 over 1 plus, no, plus, good Lord, 1 times 6, which is negative 1. So I can go to 4, negative 1, right here. And, well, okay, I can't do it standing on the side, sorry. Stand in front of it again. Looks something like this. So when we started this problem, like when we were factoring at the top, did you have any clue that it might look like this? No, you really had no idea. I didn't have any idea either. And like I said, I've graphed a lot of these. Once we got here, though, if you can kind of interpret this, Did you kind of have some idea of that it would look like that? Yeah. Even though you've literally never seen a graph like this, right? Most likely. I mean, or you definitely haven't graphed what I would say. But we put the pieces together and we got it figured out like a little puzzle. Okay? We good? All right. So let's do another one. So let's factor this guy. And we'll get x minus 3 times x plus 2 over x plus 4 times x plus 4. Do I have any point discontinuity? No. Can I, even though I can't cancel anything out, can I rewrite this a little bit better? Yes, I can. This gives me x minus 3 times x plus 2 over x plus 4 squared. Okay. All right. Are we going to get to say yes to something we haven't gotten to say yes to yet? Yes, we are. All right, let's get there. All right, so how many roots do I have? 2. X equals, we get negative 2 and 3. How many vertical asymptotes do I have? 1. X equals negative 4. If you leave it like this and you write down x equals negative 4 twice, I'm counting the whole thing wrong because clearly you have no clue what's going on whatsoever. All right, do I have any changes to your togetherness? Yes, I do. Okay, what do I have? You sure about that? Okay, let's think about this. If you don't remember, or you don't have your little foldable yet, it's okay. Let's think about where we get information from. We get our zeros from the numerator, right? Our vertical asymptotes from the denominator. Tangency deals with the zeros, right? It's where it bounces. Togetherness goes with the asymptotes. That's how you can remember which is which, okay? Togetherness goes with the asymptotes. That's what's happening in the denominator. So we have togetherness, and so since it asks in the same question, we need to say what we have. So we can just abbreviate it TOG for togetherness. And we have togetherness about an asymptote, so I just rewrite the vertical asymptote, x equals negative 4. Okay, we good so far? Okay. Do I have a horizontal asymptote? Yes, I do. It is at y equals what? 1. Slant asymptote would have to be none. Y-intercept, okay, so my y-intercept is at 0, and again, I would get it from this version of it, and that would give me negative 3/8. Way easier than substituting into stuff. I already have it. Right? I mean, nothing wrong with z. I mean, you just have to, you get the same answer. It's not that much more difficult. Okay. My sign chart here, f of x is equal to, what is it, x minus 3 times x plus 2 over x plus 4 squared. So I have 3 things that go on my sign chart. I have a negative 4, a negative 2, and a 3. Negative 4, opened or closed? Open. Negative 2, open or closed? Closed. 3, closed. All right. So I'm going to substitute in like a negative 5. So in the numerator, that would be giving negative and negative. The denominator, since it's squared, it's going to give me positive no matter what. So that's positive overall. Then I've got, between these two, I can do negative 3. So that give me negative, negative. Denominator is going to be positive no matter what. That's positive overall. Between negative 2 and 3, they give me negative, positive, positive. That's negative overall. And then 4 would give me positive, positive, positive. That's positive overall. I'm going to shade this. So this right here, this happening should make sense, right? Because what's happening at negative 4? Togetherness, yes. Good. So I have, this is where I have an asymptote, and I know that I have that togetherness here. So that's what's happening there. Okay, let's get our asymptotes drawn in. They're at negative 4. 1, 2, 3, 4. and at y equals 1. Okay, so it's not, my horizontal asymptote is not at y equals 0. So there's a possibility that this does intersect the asymptote, and I don't know, so we need to figure that out. When we do that, it is easier, or more efficient, I don't know if easier is the right words, to use this form of the function instead of that form, because in that form I'd have to multiply it all back out, and I already know what it is multiplied out. So we're going to use that form. So let me rewrite that right here. Let's see. We have f, well, I'll put y since y equals x squared minus x minus 6 over x squared plus 8x plus 16. And that is equal to, no, that is not equal to anything. And then I also have y equals 1. So I will substitute 1 in right here. So I get 1 equals x squared minus x minus 6 over x squared plus 8x plus 16. So just like on the other one, I'd like to get rid of my denominator. So I'm going to multiply both sides by this, which will give me x squared plus 8x plus 16. And that's equal to x squared minus x minus 6. Everybody with me so far? So when I start to solve it, I can subtract x squared from both sides. Those cancel out. Or they zero out. I think I'll move my x's to the left. So this will give me negative 9x. No, it doesn't. Oh my gosh, it gives me positive 9x. At least I'm catching myself here. Gives me 9x equals, and then I'll move 16 over there. That'll give me a negative 22. So x is equal to negative 22 over 9. So what this tells me is that my asymptote and my function do intersect, and they intersect at one point, okay? So it's going to intersect once, and it's going to intersect when x is negative 22 ninths. So the decimal approximation, let's see, 9 goes into 22, what, twice with 4 left over? So it's about negative 2.5. I mean, good enough to estimate on here because they're small. So when x is negative 2.5, 1, 2, negative 2.5, it's when it intersects the asymptote. So I have a point right there. Okay, you see how that works? Okay. Then let's plot the rest of the stuff that we have already. We have roots at negative 2, and at 3. And a y-intercept at 0, negative 3/8, which is about negative 1/2 right there. Okay. Everybody good with that so far? So let's see. From negative infinity to negative 4 on this side of the asymptote. This is positive the whole time. So I know not only is it positive the whole time, it is not going to intersect the asymptote over here because I've already figured out that it intersects once and it's right here. So it's going to be right here. Okay? But I need at least 1 point. So let's do negative 5. So let's see. So f of negative 5 is going to be equal to, so that would give me negative 8 times 3 over 1. Times negative 3. So that's going to be 24. So at negative 5, I'm at 24. That is way off my graph. So that does not help me at all. So I find f of negative 6. That's going to give me negative 9 times negative 4 over 4. Right? So that would give me positive 9. Right? So I can do that. Negative 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that by itself definitely is not that helpful. So I also need to find f of negative 7. Just move over one at a time, because if you think, oh, I'm going to jump over a couple, then you might have something else that's actually not very helpful, because things can change kind of quickly. So negative 7 will give me negative 10 times negative 5 over, seems louder, doesn't it? Over 9. So that gives me 50 over 9.
Good morning, Mass. Just a friendly reminder, Please remind all of our substitute teachers in the building to send a student with the attendance to the. Thank you. Have a great day.
Okay, so I need a decimal approximation to actually graph it. 9 goes into 55 times with 5 left over. So it's like 5 and 5/9, which is about 5.5. Good enough to graph on here. So I'm going to go to -7, and then 1, 2, 3, 4, oh goodness, 1, 2, 3, 4, 5.5. And that's probably good enough because, again, I can tell that it's kind of swinging wide, so it's going to just kind of follow the natural curve here. And I can't remember if I said this period or last period or both, but when you're plotting points, if your points are so light that they're like little dots, and then when you draw over it and your pencil's kind of thick, you can't even tell that you put a point, then I think that you didn't put a point. All right, so your points don't have to be ginormous, but I have to be able to see them. Amy, you with us? Somebody wake her up. Amy, you're missing all the fun. Come on, sit up. All right, so let's look at what's happening here. From -4 to -2, it's positive. So it comes down, and even if I hadn't found this point, even if I hadn't found this point yet, it would be really obvious that I am going to intersect it at least once, right? So I'm going to intersect it. It becomes negative. From -2 to 3, it's negative, so it drops down here, and then it's going to be positive again, but it has to stay underneath the asymptote because I only get to cross it once, okay? So this comes here. Then I hit that point, and that point, and that point, and then back up like that. Okay. And that's yet another completely different type of graph. So rationals there's an infinite amount of things that could look like and things that could happen depending on how things are put together. Okay, what questions you got? All right, so I want just, you can stick this in the envelope in the back or whatever, but don't tape it in yet because we're not finished. The bell's not about to ring though, so hang on. I'm going to show you what is going on in Delta Math here. Okay. All right. So the good news is this graphing is not nearly as crazy as the piecewise, which I know was frustrating. This shouldn't be frustrating. So remember, you have things you got to look for. PD, radii. I have to factor f of x is equal to x minus 5 times x plus 2. You don't have to write this down. Just pay attention and follow along. Then I factor this, and this will give me 2x and x, and that'll be a 2 and a 1. That's positive and negative. That is old school factoring without grouping. Yeah, which means you just got to know what you know. All right, so do I have any point discontinuity? Yes. So my x value is -2. I substitute in the -2. That'll give me -7 over -5. So that's 7/5. Correct me if I'm wrong. My roots, I have at 5. I have a vertical asymptote at x equals 1/2. I do not have any tangency or togetherness. I do have a horizontal asymptote at 1/2. And I have a y-intercept at -5. Okay, those are all the pieces that I have to take care of over here. Okay, so there's not blanks for you, but you got to do it before you get over here. Okay, so now I can't just say plot rational function. Can't be drawn because we didn't do anything, right? Let me start with my vertical asymptote. So when you hit that, a vertical asymptote is going to pop up over here. And then you move it to where it's supposed to go. It's supposed to be at 1/2. So I move it over here. And I know there's not a little mark for 1/2, but it's pretty forgiving if you looks like you did 1/2. Then I got horizontal asymptote. That is also at 1/2. So I click that and I move it down to 1/2. And so if I do plot rational function now, it's going to say an x-intercept is required. After I put my x-intercept, it'll say a hole is required. Like you have to have all the stuff. So it's not even going to let you finish if you haven't done it. But if it doesn't have a hole, then you don't have to do it. Or if it doesn't have an x-intercept, whatever. But I have all this stuff. So x-intercept, this point plops up right here. My root is at 5, so I move it to 5. My y-intercept is also at 5. This is a very interesting graph. And then I have a hole, which was at -2 7/5. So 7/5 is like 1 2/5. So I'm going to move this over here to -2 and like 1 2/5. Again, you make an honest effort. It's a big circle, so, they're pretty forgiving. I put all of my information on there, right? And we should know basically what the graph looks like, but then you do plot rational function and boom, it graphs it for you. But it's only going to graph it for you if you're correct. Does that make sense? It kind of makes you be correct, so you've got to go find all of this stuff. Okay, easy enough? Practice on this. Actually do some of this weekend, because on Monday you're going to be plotting them on paper after we do this last example. Okay? We good? Awesome. Also, if you need to, catch up on any other homework and your test review if you plan on doing maybe some retests. I should have the grades in today.